Hello friends, now we are going to discuss the hardware implementation of the shift microoperation. You know about what is logical shift left, logical shift right, circular shift and arithmetic shift. Now we are going to discuss the hardware implementation. If I am saying the register having the 8-bit number or the variable having a 8-bit or 4-bit number, what I am writing it here that A equals to, suppose A value is 10 and 10. These particular bit can be represented as A0, A1, A2 and A3. Simple, means LSB can be represented as A0 and the next bit is A1, next bit is A2 and A3. Means whatever the content in the register doesn't matter, this particular bit can be represented if the 4 bit is there. Now, in this particular, if I am applying SHL shift left on A, means what? In this particular A0, A1, A2 and A3, inserting 0 here, and if I am not knowing about what is the content of the A, and this particular A3 will be lost. It means what? What will be the result? That is 0, A0, A1 and A2 will be there. Now, this particular 0, I can write it as an I of L, means arithmetic shift left. Again, if I am applying shift right operation on A, SHR A, it means what? SHR A and the A having a 4-bit number A1, A2 and A3. Here inserting 0 and this A0 will be lost. So you can write it as an SHR A is what? Shift right operation, that is 0, A3, A2 and A1, and A0 will be lost. This particular 0 I can write it as an IR. So you can say that in the shift right operation, what will be the answer is IR, A3, A2 and A1. Now you can say that if the 4-bit number is A is there, A0, A1, A2, A3, then shift left operation you can write it as this one, and shift right operation you can say this one. Now if I am going to take the example with this particular example, there is a selection line, 2 lines are there, 0 and 1, and 4-bit number these represented as an output. Now at the 0 point, shift right operation will be taken place, and at the 1, when the selection line is 1, then shift left operation will be taken place. So shift right operation, what will happen for this? IR, A3, A2 and A1, and at the when the selection line is 1, left operation will be taken place, shift left operation, then what will going on? That is A2, A1, A0 and I of L. It means what? You can represent it with the circuit. Selection line is 1, so you can make a multiplexer, because I am going to take some selection and the output is only single. So you can take as a multiplexer. There are 4 bits, so I can take 4 multiplexer. 1, 2, 3 and 4 multiplexer will be there. Now in these particular 4 register will be 4 multiplexer having what values will be there? That is the first selection line is there. Selection line, only one selection line will be there, and the multiplexer is what? 2 cross 1 mux is there. This is 2 cross 1 mux. 2 cross 1 mux, and this is again a 2 cross 1 mux. Now what is going on? 2 cross 1 means there are two values, 0 and 1, 0 and 1. These are the input values, 0 and 1. And this particular selection line is there. Suppose this is your selection line, that is S. S goes to each and every multiplexer. Now, the output is what? H0, H1. Output is H0. Next is H1, H2 and H3 is there. When the H0 is taken place, the input will be IR and A2. It means what? At the 0 side, IR will be there, and at the 1 side, A2 will be there. Simply you can write, when H1 output will be there, then A3 and A1 will be there. It means what? At the 0, A3 will be there and there is A1 will be there. In the H2, A2 and A0 is there. A2 at the 0th, A2 is already, I have a line, so I can connect this wire with the A2, and next is your A0 line. A0 line you can write it as A0. Again, when the H3 is the output, then A1 is there. A1 I already have, so I am just writing it here A1, and IL is there, so this particular line represents as IL. This is the simple hardware implementation for the logical shift left and logical shift right micro operation. From the same, you can create a circuit for the arithmetic shift left or arithmetic shift right, or circular shift left or circular shift right. This is the main hardware implementation of this, of a shift micro operation. Thank you. Now we can check that shift left and shift right operation when we are using, then the shift left operation is treated as an IL of A0, A1, A2, and shift right as IR, A3, A2 and A1. So I can create a function table for this one, that is the selection line, because two operations is going on, shift left and shift right. So the function table having a selection line, this particular selection line is 2, that is S, that is 0 and 1. Now the output will be, because the 4-bit number I am taking, so there is a 4 output will be there, H0, H1, H2 and H3 will be there. Now what will happen when the selection line is 0? When the selection line is 0, at that moment, what is going on? When the selection line is 0, the arithmetic shift operation will be taken place. That is a shift right operation will be there when the selection line is 0. The shift right operation is what? You can write it as IR, A3, A2 and A1. And the next is, when selection line is 1, at that moment what will happen? That is a shift left operation, that is A2, A1, A0 and IL is there. Now if I am going to create a circuit for it, what is going on? Because the selection line is only 1, I know that what will happen, which type of components I have to create for hardware implementation of shift micro operation. Here you can see that there is a 2 selection lines. There is not a 2 selection line, there is only 1 selection line. Only 1 selection line means what? You can take multiplexer as a 2 cross 1. So, and here these 1, 2, 3, 4 outputs will be there. So you can take 4 multiplexers. And 4 multiplexers are there. These 4 multiplexers, you can say there is a 1 selection line, means 2 cross 1 mux is there. So you can write it as mux 2 cross 1 having 0 and 1. Two inputs will be there, single output will be there, and one selection line will be there. Next, again you can write it as mux 2 cross 1 is there, 0 and 1 is there, S and 1 output will be there. Same repeating steps, 0 and 1 is there, output is there, S is there, 0 and 1 is there, mux is there, and 2 cross 1 is there. Now, the selection line is also there. So, for the selection line, you can take this selection line. Selection line will go each and every multiplexer. Now, what is going on? The output will what? Output is H0, H1, H2 and H3. So, you can write it here. H0, H1, H2 and H3 is there. 0 and 1. When the 0, then shift right operation will be taken place. When 1, the shift left operation will be taken place. So you can write in the H0, IR and A2. H0, when the 0 selection line, then IR will be taken place. So at the 0 side, you can take as an IR, and the 1, there is an A2. Now, at the second multiplexer, output is H1. Output is H1. At that moment, A3 and A1 is going on. So, there is a A3 and there is a A1. Next, 0 and 1, H2. There is a A2 and A0. A2 I already have. So, I am taking, just connect this wire from the A2 and A0 is there. So, A0 is there. Next, H3 is there. H3 having A1. I have also a A1 is there and I of L is there. This is your IL. So, this is simple implementation of the logical shift left and logical shift right hardware implementation. Thank you.